All right, welcome back to another one. Today we are continuing on our previous video of seeing how we can parse a Scala trait into a whole HTTP server and eventually an HTTP client. Today we're going to be mixing it up a little bit. The previous videos in this series, I've been doing a sort of code along with me where I implement stuff with macros. I've noticed a lot of you are subscribing at a very high rate, but not a lot of you are watching the video very long. So we're going to keep it a little more condensed today. I'm going to focus more on what we were able to achieve as opposed to doing the whole thing code along with me. Okay, so to highlight where we made it in the last video, we were able to parse the tree of this trait and these function definitions and these parameters into this sort of structure here where we could detect these const paths that we need to parse and these path params we need to parse, and where we parse them out of order because you notice we intentionally threw this query param in the middle between the paths, but since we care about making sure the path is right first, we're going to parse ID and then P2 and then this query param 1 afterwards. And then when we actually are able to instantiate our function, we sort them back into this call order where it's ID P2 P1, but in our call order it's ID P1 P2. And with macros, all of this not so bad. So here we can see that what we were able to do is we're doing this path decoder stuff here for units, and for the unit we're kind of discarding the value that we parse, but for the actual params we keep track of this where we have path param and path param, and then when we actually instantiate it kind of gives us this little sub 2, which for some reason it doesn't give us here, but that's what this is. This is path param 2 and this is path param 1. So yeah, all of this, and if I ever change something, like wherever here, I call that P3, and now we can notice here that this is called P3, or that's not really that important. It'd be cooler if we did this, P4 for the query param, and now the actual query param, where is that located? Path decoder. Here we go, single param decoder. We notice that we're actually, where is that? Here, yes. So we're looking at we're looking for the query param labeled P4. So it's using what it's parsing out of our function to actually parse the values out of the HTTP request. Very cool. And we can see an example of how this actually works here. You can see that we've sent all of these kind of fake little HTTP requests that I've put together. It's all not fully together where we can actually have a server running and such, but we can parse our little fake HTTP requests at least. Let's see. You notice here we have an actual implementation of our user API, which is defined here. And with that implementation, we're just kind of doing a simple thing with a ZO ref. And what that then lets us do is, if we look here, when we do I have these side by side. When we do get all users, you notice that it kind of returns us nothing here. And then when we try and get this specific user with ID 1 and just these kind of useless params that we tacked on, you notice that oh, I need to. It's funny. The example is working because it's not working when we change stuff. Let's rerun this. Okay. So we can see here that we have no users, and then when we try and get the user with ID 1, we get this none and the params that we passed in. Then we create a user and it's auto incrementing the ID as our little fake impl is supposed to. And when we get all again, which now we're here, we get all of the users. And when we try and get it by a specific user ID, and then when we do this search and filtering, last is L1, last is L2, exactly as we'd hope it be. Okay, so that just shows us that, in fact, the magic does work. And so now we can take a quick look at how it works to keep it nice and sweet, short and sweet. Okay, where are we going to look today? Route. Okay, so to dive into looking at what our code actually generated here, we can see that what it's doing, or what we're trying to parse, is one of these endpoints, which is an HTTP request to an option of an effect of a response. The reason we have this option is because, if it's not the right route, we want to return a none. There's no reason to return an effect, which is also the reason why we're parsing the entire URL first before we're actually trying to parse any like query params or headers or bodies and such like that. Okay, so let's look at this. We notice that what it's doing is, the first thing is we're creating this decoder for, geez, a lot of reading this generated code is a little tricky sometimes. So we get a decoder of unit, which is parsing API, which makes sense. Then we parse user, which makes sense. And then we have this percent, which correlates with this ID, which makes sense here. We have this path decoder of long, and then we have another const decoder, presumably of P2. Yep, const decoder of P2. Then we decode this path decoder of string, which makes sense because our next thing would be this. And so you can see how it's all just doing this nice and recursively. And so if I just kind of arbitrarily took out this user and regenerate the code, you notice, like magic, this just disappears. And if this would be super nice if we had our, our server and our endpoint deriving from the same thing, and there's no boilerplate going on here as far as, like, if you're using Tapier, you have to define an endpoint and then use the endpoint, and the endpoint needs to forward the response to some like ZO trait that you're using, or ZO service, like API, user API, and then you have like a user client. It's all in one place. You update it in one place and it fixes itself everywhere. Okay, so now the next thing we will hint at is taking a peek at how we were actually able to generate this nice recursive function that does what we want it to. So that's going to be here, and we want to look for loop 1. Okay, so if we look here, we have this to endpoint, which is calling our full execute, which full execute is kind of a little helper here that's kind of combining these three functions in the way we want it to. So what we really want to look at is our execute function. Okay, so here we could see that the first thing we do is, like, if the method is not right, we're going to return none. And so let's look at that code there. If method is get, then we actually do parsing. Otherwise, at the end, we have this else none. So it would just look for the next thing if we're looping over a bunch of endpoints. So the first thing we check for is that, and then we go into this loop 1. Loop 1 is where it starts to get interesting. So we have this sort of queue of our path params, which this path param could either be this const path or non-const path that we saw here. And so when we're looping through this, then what it's doing is, for const path, is we're creating these decoder of units. And if you notice here how, like, this is the param we're parsing, but it's unit. So in our code, we just kind of write this as underscore, and it's giving us this underscore, ignoring the param as we'd hope in our generated code. And then in this one with the non const path, where we actually care to parse our param, then we are doing it as such, where we actually get this somewhere. Yes, our path param here, like that. So yeah, that's a highlight. I will say, if you guys have anything you're interested in seeing, um, barring any suggestions, my plan is that for the next video, I'm going to finish this up on my own and give some real world examples of parsing actual HTTP requests, hopefully with like Postman and a server running. So that's all I got for today, and have a good one.